Hello everybody, my name is Jeremy Sue. I work for Burn Design Lab as a mechanical engineer and project manager for this improved Shea roaster project that we have going on in Ghana. A little bit about Burn Design Lab. We are a 501c3 nonprofit based in the US, and we develop clean cook stoves and productive uses of energy for different communities in low and middle income countries. Shea roasting is one of the steps in the process of making handcrafted shea butter, and this is currently done in not only Ghana, but the entire Shea Belt, which is a large portion of West Sub-Saharan Africa. And in Ghana alone, there's about 78,000 kilometers of land that is covered in these shea trees, and more than 600,000 women are involved in some aspect of this shea butter process. Current methods to roast these nuts are very labor intensive, as you can see in those images on the right. The women are forced to either sit by the fire and smoke all day or bent over, rotating that drum, which is very hard on their backs and their arms, as they've told us through user feedback. This isn't to mention the amount of firewood that is being used and cut down in order to roast these nuts, which is not good for the environment or the local forests, but also the women that have to breathe in all the smoke due to the inefficient burning of the firewood. Here you can see a video of these being used in operation. And as I mentioned before, the amount of fuel being used leads to significant amounts of forest degradation and also harmful effects for the women that are operating these roasters. And this is how we aim to help. So our objective is to develop an improved shea roaster for handcrafted shea butter producers in West Africa, and we hope to reduce the wood consumption by at least 40%, reduce PM 2.5 exposure to the woman by at least 90%, deal with the ergonomic issues faced with traditional roasting technology, optimize the combustion chamber for shea cake fuel consumption, and also be able to be manufactured locally in country. Starting in 2017, we started with the initial project scoping and initial research here located in the city of Wa in Ghana. And as you can see, the women are roasting together in groups as they normally do, sitting around the fire and smoke all day together. And you can see the amount of wood that's being used in these traditional roasters in the image on the right. In 2018, we sent a team to collect baseline data of these traditional roasters, utilizing different methods for collecting the mass of the firewood, the moisture, and the amount of energy being put into the drum, so that we could calculate the thermal efficiency and whatnot of these traditional shea roasters currently being used. Starting in 2019, we brought our first prototype over to Ghana to conduct field testing and get user feedback from the woman. However, in 2020, we did work on some of those issues and focused on reducing the size of the drum and introduced a better sheet metal design for the riser and shroud section, which is above the firebox. However, due to the COVID-19 pandemic, this prototype only made it as far as our parking lot out back of our warehouse. During that time of the pandemic, we also started the development of our economy prototype, which was meant to be cheaper and easier to manufacture in country of Ghana. So starting in 2021, we did bring our first economy prototype to the field in June, and we got a good amount of field prototype data. However, there were some issues with collecting it and the schedule and whatnot. We had to be flexible. So what we ended up doing was refining this design and returning back in November with Economy Field Prototype 1, which I'll be presenting on the design and also the results here. So as you can see here, with our current design, we focused on reducing the size of the combustion chamber, insulating it with some ceramic bricks, and adding an additional door in order to improve that fuel efficiency and reduction in fuel use. And not to mention also the optimization of shea cake fuel, which is a biomass residue from the shea butter process itself. So above the firebox, you can see the internal design and geometry of this riser and shroud section, which allows for even heat distribution to the drum along the axial length. The dual wall lid traps the heat and the smoke within the drum and not exposing it to the user, and the two chimney stacks allows for natural draft to bring it up and away from the user's head and breathing area. Not shown in these images is an internal thermometer that is used to inform the users of when the roast is actually done. With these traditional roasting methods and traditional drums, the women have to open and close the drum itself to check the doneness of the nuts using what we call a kind of a water test by sprinkling water on it and listening to see if it sizzles. And this not only cools the nuts down and releases a lot of heat from the drum, slowing the process down, but it also adds another step where the woman could burn themselves or hurt themselves by opening and closing the hot drum. And lastly, one step that we did following the field prototypes 1 and 2, we enclosed the entire design with sheet metal so that we could prevent any heat and smoke exposure to the woman that might cause burns or other safety concerns. Here's a video of our prototype roaster optimized to use Shea cake briquettes that also have a little bit of rice husk in them. And you can see there's no smoke coming out of the front, so it is optimized for that Shea cake fuel. And there's also no smoke coming out the top. And this is a huge step for us because we've been pretty much able to eliminate the amount of wood use in this process, which is a great step in the right direction for the sustainability of handcrafted shea butter. They can also use wood, as you can see in this video here, although it is a very significant decrease in the amount of wood being used. And it is burning very clean, opposed to those traditional methods where you saw a lot of smoke coming out the front end over the top of the drum, whereas ours is burning very cleanly. So switching over to a little bit about the performance, we were able to conduct about 26 tests in 7 different cooperatives while we were there this past November, and we averaged about 37% thermal efficiency, whereas compared to the traditional methods, we were only getting about 15%, which we've seen in literature values and then also baseline data from 2018 through 2021. We've also reduced the firepower from 39 kilowatts down to 11. However, we also decreased the roasted shea output from 59 kilograms per hour to 43 kilograms per hour. With that said, we did get some lower values in our baseline testing in 2018 and 2019, averaging about 34 kilograms of roasted shea per hour. However, we are working to match at least that 59 kilograms per hour in this pilot design going forward. In doing so, we're going to work on the design, but then also work on the firebox and combustion chamber to optimize for around 16 kilowatts, which should put us about that 59 kilograms per hour with only a slight reduction in that thermal efficiency. We are also able to measure the amount of emissions and fuel savings with our prototype when compared to the traditional methods. As you can see on the left, we were able to reduce the wood consumption by 97% when using our roaster and switching over to Shea cake as that main source of fuel. Secondly, we've also been able to reduce the amount of personal PM2.5 exposure to the woman by 74%, all the way down from 606 micrograms per cubic meter down to 160, which is a great step in the right direction, but we are aiming for that 90% reduction at a minimum. With that said, we have gotten a lot of great feedback from the woman, especially noting that lack of smoke and heat exposure when compared to the traditional methods. And one of the quotes that really stood out to me was this last one by Sanatu, a processor over at Donda, where she told me that at the end of the day, she didn't even feel like she had roasted. And to me, that meant a lot and meant that we were definitely on the right track, because with the traditional methods of roasting, which I and other members of the team have done, is very labor intensive, and you're pretty much sitting over an open campfire with the smoke getting in your eyes all day. So the fact that she didn't even feel like she had gone through that strenuous process using our roaster was very assuring to me and the rest of the team as well. So going forward, we are going to be working on this pilot program, which is the next phase of the project. And this is going to consist of both the design for manufacturing and also the prototyping and pilot models being manufactured in country. So this is going to involve a lot of work with the local manufacturers, doing technology transfer from both ends, and then working with them on equipment and manufacturing methods to produce these efficiently. We're also going to be in the field with the woman, training them on operation of the roaster and collecting user feedback and data collection over this monitoring and evaluation period. In order to get this all together, we are working with the Global Shea Alliance as our main partner for this project, along with other organizations in the country of Ghana as well. As I mentioned before, our main goal for this project, this pilot phase of the project, is to partner with one of these local manufacturers to establish local manufacturing of the improved roaster design that we have made and meet these following KPIs. We want to have at least 8 roasters in the field, all manufactured in country, and processing about 250 kilograms of raw nuts per week. We hope to reduce the amount of fuel by 40%, reduce the amount of PM 2.5 emissions by 90%, and have at least an 80% adoption rate. Looking ahead to the schedule, we are in this pilot design phase, working on the design for manufacturing with the manufacturer in Ghana, and we hope to do some lab testing here in our new lab as well in this first quarter. And then in April 2022, I hope to travel over to Ghana and work with the manufacturers to design and build these 8 models, at least 8 models of the roaster. And in June, we hope to install these into the field and train the woman on the operation of it, and then ramp up for the monitoring and evaluation period that should extend throughout the rest of the year. Simultaneously, I'll be working on the production system design, along with others on the team and the manufacturer themselves, and by November of 2022, we should have that final design of both the roaster and the production system so that we can build it out and ramp up for production in 2023. In order to make all of this happen, we do have a budget of about $250,000, and in order to raise all of these funds, we've partnered with the Global Shea Alliance and other local partners in order to both raise awareness for the need of this technology as well as raise joint funding for the project itself. Thank you all for listening and watching this presentation, and again, my name is Jeremy Sue, and if you have any questions about the project, I'd be more than happy to talk about it during ETHOS, but also feel free to shoot me an email here on my email below. If you would like to support our project or learn more about the project, you can follow that link below as well.